Hi, in this video, I will be showing you problem number 31 of chapter 14, section 4. If z equal to 5x square plus y square and x comma y changes from 1 comma 2 to 1.05 comma 2.1, compare the values of delta z and dz. So first we should understand what we mean by delta z and dz. What is the difference between the two? If z equal to f of xy, what are the differentials dx, dy and dz? The differentials dx and dy are independent variables that can be given any values. If f is differentiable, then dz is defined by dz equal to partial derivative of f with respect to x comma y at x comma y times dx plus partial derivative of f with respect to y at x comma y times dy. This is what dz is. It's more like coming from the tangent plane. Delta z is the actual difference in the z, which is f of x plus delta x, comma y plus delta y minus f of xy. So this means these are the new values, something like 1.05, 2.1 in the problem. And xy are the original values of x and y, which is 1, comma 2 in the problem. So delta z is the value, the difference between the value of the function at the new values of x and y and the original values of x and y. That is the difference. That is delta z. So we got these two, delta z and dz. Let's find out dx. Dx is independent variable which can be given any value. We assume normally dx and delta x to be the same, and also dy and delta y to be the same. So from these two values, what we need to determine is dz, the differential of z, and delta z. These two values we need to determine. So dx, delta x is 1.05 minus 1. The new value of x to the original value of x. So 1.05 minus 1, that will be 0.05. dy is nothing but delta y, which is the new value of y, the difference between the new value of y and the original value of y, which is 2.1 minus 2. That will be 0.1. So we got the value of dx and we got the value of dy. So z is 5x squared plus y squared. So we can determine f sub x, which is the partial derivative of f with respect to x, which means you are going to keep y as a constant and differentiate z with respect to x, which is dou z by dou x, which can be written as 10x, which needs to be evaluated at the original value given in the problem, which is 1, comma 2. So x is 1, so it is 10 times 1, which is equal to 10. So partial derivative of f with respect to x at the point 1, 2 is 10. Same way, partial derivative of f with respect to y is keep the x constant and differentiate with respect to y. That will give us 2y. Evaluate that at 1, comma 2, which is 2 times 2, which is equal to 4. Now, we have to determine dz, which is f sub x at 1, 2 times dx plus f sub y at 1, 2 times dy. We got all these values already evaluated, fx and fy, and we also know what dx and dy are from above. So if you substitute all those values, you get 10 times 0.05 plus 4 times 0.1. which will be 0.5 plus 0.4, which will be 0.9. So the differential of z is 0.9. Now we will find out the actual difference in z, which is denoted as delta z. So keep in mind, the idea is that instead of finding delta z in the problem, which is normally difficult because of the nature of the surface, so we go in with the differential, which will be almost equal to the actual difference of z. That's the whole point of this. We will be approximating the values of the function on the surface by the values on the tangent plane at that point. So, which will make the problem much easier. This tangent plane is after all linear. So, getting the values on the tangent plane in replacement for the value of the function on the surface will be much simpler. So delta z is f of at new values, which is 1.05 comma 2.1 minus f at old values, original values, f at 1 comma 2. F is given in the problem as 5x square plus y square, that is z, 5x square plus y square. So substitute x equal to 1.05 and y equal to 2.1 for the first, f of 1.05 and 2.1. For the second, you plug in x equal to 1 and y equal to 2 in that function, and then get the difference. It will be equal to 5 times 1.05 square plus 2.1 the whole square, and minus function at 1, 2, value of the function at 1 comma 2. So it will be 5 times 1 square plus 2 square in parentheses. If we evaluate this, it's going to be 0.9225. If you notice here, dz is 0.9 and delta z is 0.9225. So this 0.9 dz comes out of the tangent plane. Delta z comes out of the surface, finding the actual value of the function at these points, that is coming out of the surface. So the difference is not significant. The difference is not too much. So dz and delta z are almost equal. So dz is 0.9 and delta z is 0.9225. So the difference is not as much. Hope this video helps.